The subtitle to this is actually yak shaving, or how I ended up learning about PCB design in order to control my home heating. I trust there will be some useful information as well as a lot of useless information. I'll put these slides up somewhere within the next week, and I'll tweet it. I've got a whole bunch of things I'm going to go through. It's actually a talk I've put together from a bunch of blog posts I've done. So I have links on every slide and some references to other bits and pieces. So if you actually want to get into the details about any of the home automation I've done. I had some initial motivation and some requirements. I'm going to talk a lot about things I did which aren't directly related to what I ended up doing, which was kind of the interest for me. But the takeaway I'm hoping to give you is that there are some interesting things you can do with building your own home automation setup rather than buying something off the shelf. For me, there were a bunch of advantages in that I'll talk about as I go. The links will talk about some of the ways you can buy stuff off the shelf if you're not comfortable sort of hooking things together with wires or soldering stuff, or you just don't have the time. But I did start with a requirement. I did actually start. So I moved house, and my previous house had 7-day heating control, and my new house had a 24-hour heating control, and I never realized I wanted a 7-day heating control until I didn't have one, because I like to lie in at the weekends and I don't like the heat coming on and waking me up in the morning if I'm trying to have a lie-in. So I really wanted 7-day heating control, and the right answer is probably go and buy a Nest or something like that. And I'm not particularly good at going and buying things off the shelf. It's like I could do that better. So looking at this, I mean, I don't know if it was Nest, but there was one of the Nest setups had a problem whereby they turned off the functionality. Because it's all run through the cloud, there's a requirement that that cloud service keeps running, or your system doesn't do what you paid for it to do. And sometimes those fail in graceful ways where you can still do local control, but you always lose some level of functionality. So that was important to me, that I ran this and it ran on my infrastructure and it worked. And in particular, things like it worked when the internet went down. I didn't want my home heating to rely on an EC2 instance. That meant that if my ADSL went down, then all of a sudden I didn't have heat anymore, because you know it's going to go down when there's a bad storm and it's cold outside, and then all of a sudden your heating doesn't work and the lights are a bit dodgy and you've no internet, and all of these things happen at once, and that's never fun. I did have other home occupiers to consider. My wife is extremely tolerant of me building stuff, but she kind of likes the heat to work, and that seems reasonable. And equally, there's a usability concern. It's all very well to build home automation for just one person where you know where everything's done. My friend put his heating on his internal network about 20 years ago. He did it with a PIC controller, which is a tiny microcontroller, which was wired via a serial connection to the computer in his attic. And in order to change the temperature setting that he wanted, he had to log into the machine in the attic and do it via text interface. And he wrote lots of complicated code about hysteresis and trying to maintain the static temperature and lots of clever stuff. And understandably enough, his wife hates it because she doesn't want to log into the machine in the attic and do this to change the temperature control. So there is a thing when you build this about, is it just me living in the house? Do I share the house with someone else? What about guests? I'll talk a bit about my in-laws visiting and how that changes some of the dynamics. The other thing is that I'm not a DIY person. Like I can put a picture up. That's what I can do. I can drill holes in walls. I'm good at destruction. I'm not particularly good at drilling holes in walls and then covering them up afterwards. Unless it's with a picture, I could do that. So that's sort of where I was starting from. And this is the remote control. This is what was sitting in my hallway, controlling my heating and sort of being sort of quite dull, but ruthlessly efficient at what it was meant to do. It did turn the heat on, it did turn the heat off, but all good. So I started out by looking for some home automation software, and the piece I found, I've looked at several over the years. I know there's a talk about OpenHAB or touching on OpenHAB after this in this room. I didn't like it when I tried it. It was too complicated. There were 5 years elapsing between me trying OpenHAB and then trying Home Assistant. Home Assistant is lovely. It's a piece of Python. It supports just about every single piece of home automation that I've thrown at it, and many more that I haven't. It's actively developed, it's available there, it's Python, they take patches, they're lovely people, and they're good. They've got this self-contained HAS.io. not actually the domain, they just call it has.io, but it's available from homeassistant.io, which confused me. But anyway, they've got a self-contained Raspberry Pi installed right onto an SD. Just go. I happen to have a server already running that runs Debian. I put it in a container. It works just fine in a Python virtual env. It pulls in all the dependencies under the sun is the problem, because essentially all of the home automation systems it supports are supported via Python modules, so it actually has to pull those down. And that's one of the things that annoys me about it. There's no way to tell it, build me a static install and never download again. It downloads them as you enable things in the configuration, which I'm not particularly happy with. But other than that, it's an awesome piece of software. This is a screenshot of it on my phone. It's sort of got a nice reactive web interface that works just fine, and the website works just fine on that. So that was my core control software. To hook it all together, because I don't do things the way that you should easily do them, but the right way to do it is you put Home Assistant on your Raspberry Pi, you put it on your home network, and you give it access to everything that's on your home network that you want to control, and that's nice and easy, and you've got one central control point that does everything, and that's good. My home network is segmented. My wired network has two separate wired networks, one for sort of things I don't trust like the TV, and then one for things that I wire up like my laptop and my servers, and then the Wi-Fi network's a separate network again. So things like auto discovery don't work when you have a model like that. They all look for broadcast packets, and that's what Home Assistant will pick up on, and it's very good at that. But as soon as you start to segment your network, that doesn't automatically work. So I had a problem there. The other thing was when I started out, because I hadn't been that clear on whether I wanted to stick with Home Assistant, I didn't want to get tied into my control software separate from my actual monitoring side of things. So what I ended up with is a thing called MQTT, and I can't remember what it stands for, message queuing. It's a message broker, so you end up with things send messages to MQTT, and then it publishes them out. So all your sensors send data to MQTT, the MQTT server, and then Home Assistant listens to that and sees those messages. So it provides a single point. So this is a BT Home Hub, which is not actually connected to a BT ADSL line, but this is a fantastic OpenWRT router. It has like 128 megs of RAM and can run lots of things, and most importantly, it is actually the thing that's routing between all my networks. So it sees them all, so it was a good point to put MQTT on. And I use this thing called Mosquito, which again is sort of excellent free software that you can download and runs on everything. There's already a package in OpenWRT, there's a package in Debian, and that works. And because I'm doing this right, I actually have a proper SSL cert from Let's Encrypt running on this. So MQTT supports TLS, so my devices actually use TLS even though it's on my internal network. They actually all NTP time sync, so one of the problems you hit is if you forget to renew your Let's Encrypt cert every 90 days, then your home automation goes, hey, your certificate's invalid, I'm not talking to anything anymore, and until you fix that, it doesn't work. So comes the problems, but at least I know that the timeouts work. So yeah, so this sits and it talks to everything, and then Home Assistant sits on top of that, and all the sensors talk to that. So that was my initial infrastructure for how I was going to build my system. I had some control plane software, I had some message passing structure. Then I actually needed something to actually listen to or control or something, and I did the easiest thing possible. I do actually have a Raspberry Pi. So this is a Raspberry Pi. This is actually an original Raspberry Pi. It's a classic. It has sort of like 256 megs of memory rather than 512. It's really slow, it's really good. So, but it is the most complicated temperature sensor in my house because that's all it does. This is a BME 280, which is available for about £3 off eBay, and it does pressure, temperature, and humidity monitoring. And literally, these three wires plug into three wires on the Raspberry Pi header. There is no soldering required to this. This is the simplest way you can actually build. These modules are like, you can buy the Arduino modules on Amazon, and they all come with pin headers on them, and then you buy some wires that have the pin headers already on them, and you plug them together, and it's great because then you just write software. And this is not quite the software I'm running, but this will effectively query the device because the Linux kernel supports it and exports it as a set of devices. It reads the input from the temperature input. It happens to be scaled, so it divides it, and then it publishes it to the MQT location study temperature, and that's it. That's pretty much doing that once a minute. there we go. That's nice and easy. That was good. This is actually sitting on the floor in my study where it's still sitting since I built it. And I was like, right, okay, so I could put that in the living room because really we don't care what the temperature in the study is for the house in general. But then I've already got a media PC in the living room that's already on, so I could use that instead. And at this point I actually did go looking for something that I'll buy a temperature sensor that will plug into the media PC and I'll do the same thing. And I did find a temperature sensor that plugs in. There's a thing called a Temper USB, which is a USB stick that plugs in and does temperature and reports it over USB, and there's a Python module that will talk to it, and I could have plugged it into the MQTT stuff. And I was like, actually, I have a temperature sensor. I have a microcontroller that has a USB port on it. I'll build my own. And I actually spent some time implementing firmware for this, which is an AT Tiny, to look like a Temper USB. So instead of just designing my own protocol, I went, hey, there's a perfectly good protocol, I'll do that one, and wrote this device that you plug in and it looks like the same thing and therefore runs all the same code. So yeah, I shaved another yak. And this actually has been, this is the actual device that has been determining the temperature for my heating turning on and off for the last year. I've actually changed it recently for various reasons, but it's been working just fine. So yeah, and then that was good. So I had temperature monitoring in the study and I had temperature monitoring in the living room. And I was like, okay, what else can I do? And then a friend pointed me at these things. This is a Bluetooth temperature and humidity monitor. And it does Bluetooth low energy, and this is actually, because it's standalone, it takes a single AAA battery. I put it in the bathroom. I mean, I'm not going to run power to it. I don't want to run a microcontroller in there, but I'm kind of interested. Does my bathroom stay overly humid after I've had a shower? Should I be leaving the window open longer? I was kind of interested in that. But you know, I couldn't just leave it. I'll use the Python module that comes with Home Assistant and do the Bluetooth thing. So I learned some Go. Because what it actually turns out is everyone who talks to these things actively goes and says, hey, what temperature is it? Hey, what temperature is it? And that's a two-way Bluetooth communication where it actually goes and does a connection and then gets the data back. And these things actually just spew the information out every 2 seconds. They say, hey, this is the temperature, this is the humidity, and whatever. So I wrote some Go that did some passive monitoring, which actually means the battery life lasts longer than this, and I got to learn some Go, which was nice. So we've got 3 sensors, and then we sort of get into, right, so we've got sensors, what does that mean? And this sort of comes to another aspect of home automation I think we need to think about more, and that's the privacy aspect. What do sensors tell you? Okay, this is the humidity in the bathroom. Does anyone want to guess when me and my wife showered? This is the temperature in the kitchen. Does anyone want to guess when I made dinner? It's here. The other one I had was the one beside the living room door, which I haven't captured recently because it's more prominent in the winter, is you could tell when the front door opened. There was enough of a breeze and enough of a drop for, you know, just a 1 minute, one of the 1 minute things would see an instant drop and you go, okay, that's actually when I went to work. This is stuff that we're freely giving out to cloud-based services that are collecting our information. And while it might not be, you know, the end of the world to know this information, and you could easily tell when I leave the house by watching it or whatever, and it's roughly the same time every day, it all aggregates up. I mean, I can at points tell when people have been sleeping in our spare room, because the humidity level does actually go up when they go to bed and stay sustained in a way that it doesn't when the room is unoccupied. And these are cheap sensors. They are monitoring once a minute. I'm not doing anything clever with them. It just happens that the temperature sensors I use have the humidity monitoring in them, so I may as well look at it as well. So these are things we should think about. And when you get to that one, the next thing, so I had temperature monitoring for my home heating, and I could have at that point hooked it up to, it's a thermostat, it could have done everything. We need to get the control, but we'll get to that in a minute. But I wanted the whole Nest thing of my heat's only on when I'm at home. That seems like a cool thing to add in. I mean, I should have this information. And that gets to be a bit more creepy. So you could do GPS notification, and some of these things actually run an app on your phone where they know when you leave work. So it says, right, I've left work, and therefore the heat comes on, and that means that by the time you get home, the house is already warm, and that's great. wouldn't have worked in my case in that quite often I leave work and I go to meetups or whatever, and it's hard to predict whether or not I'm going to a meetup in the evening when I leave work or if I'm going home. So I didn't really care too much about that. Also, it did seem a bit creepy, even if it was me sending detail about mine and my wife's location to our server and tracking. It just seemed, I didn't like it, she didn't like it. What's useful in terms of being in the house is phone Wi-Fi. So if you're actually in the house, then your phone's probably on the Wi-Fi. You mostly take your phone with you and you leave the house. Therefore, that's a good approximation of, is there anyone in the house or not? Home Assistant can actually scrape a lot of the common router interfaces and do a query of what has a DHCP lease, and has recently been seen in terms of ARP. I, of course, didn't use that. I used it as an excuse to learn about Netlink and ARP, and that was primarily because the OpenWRT router scraping is a polling mechanism. You have to actively go out and query the web interface sort of every 5 minutes, every minute, however often, whether the device is there or not. Whereas I actually could run something on the router that every time it saw an ARP from one of the devices would be able to publish a message to MQTT. So that's as soon as your Wi-Fi device connects to the network, the system knows. So before you're even in the front door, the heating can already have turned on. So it's not quite as good as it's on like 10 minutes before I get home, but it is on as soon as I get in the house, which is quite nice. But this was interesting as well, because then a few problems we hit with this. First of all, if your home heating is only coming on because it thinks you're in the house, if your home heating for any reason decides you're not in the house, like your power over Ethernet link to your Wi-Fi access point goes down overnight, then your heating doesn't come on in the morning even though you're there. So there are things you have to watch out for once you sort of get more intelligent on this side. And the other thing was I had to add my father-in-law's phone, because he would come and mind my kid on occasions, and then we would leave the house and then it wouldn't think there was anyone in the house, and then it would turn the heating off, and that was no fun for anyone involved. So, you know, even in terms of although they have access to the various interface to controller, it still needed to know about presence to know they were there. And there's some overrides we got built in as well now that mean that we can flick a switch that says leave the heating on even though you think no one's here. But it's just something you suddenly have to think about. As soon as you have more than one occupant in the house or you have guests visiting or whatever, there were extra things I had to think about. So that's all been about sort of sensor stuff. The next bit was the control, and I don't want to play with mains electricity. It scares me. The heating was already using sort of one of these remote temperature sensor things that actually signals back, which seems to be common in sort of recent installs in the last 5+ years. So that was quite cool, because that meant I could just take advantage of that. It's a 433 megahertz standard thing. You buy one of these for £1 off eBay. And you basically on-off key it, you turn it on and off. And you can't see the links, but they are actually clickable on the thing. Someone had already decoded the format for my central heating system, so I knew the rough shape of it, and there's like a unique code ID in it, and as soon as you watch it once, you can see what that code is, and then all of a sudden you can basically send something that turns your heating on and off without having to touch mains at all, which is really very cool. It also meant that if this goes really wrong, I can just put the battery back in the thermostat we already have and it keeps working, which is kind of a nice fallback. There are commercial options available for this. There's this thing called the Broadlink RM Pro that does IR transmission and 433 megahertz transmission, so it will control a whole range of devices in your house, and of course it's supported by Home Assistant. This is quite cool. I then also did it to control some power switches I had. So that got me to the whole controlling my heating thing. Could be very brave, and if this works, it'll work. So this is actually my home heating setup as configured by Home Assistant. So obviously you can see I've added a bunch more sensors and a bunch of other bits, but the thing I ended up doing, which is mostly just if I can work, is I built, this is all YAML configured, and these days they've actually got a more graphical configuration thing where I've got a weekend timer and a weekday timer, because I didn't really care about starting and stopping, and you can see that, you know, where's my thing? This is by default, the heating is currently set to aim for 5 degrees because there's no one at home. And this is the temperature it currently thinks it is in the living room. This is when it came on this morning. This is the target temperature, and these are the temperatures of various things around the house. And this has been kind of interesting to watch actually how much the heating's been on and off. And it works, it does the trick. It's better than what we had before, which is nice. So that was my initial goal. And once I had this, I started building other pieces into it. And the first thing I did was lights. And there are a bunch of off-the-shelf devices that are designed to talk MQTT or something similar to it, and will do mains control for you, so you don't have to worry about it. The problem with them is that they all need firmware hacks. So although I didn't have to make any modifications of the hardware in this, I had to get into here to sort of 3 pinpoints to do a serial connection to put a new firmware on it. And I don't have a good suggestion for one of the devices that don't. It's all very well documented. You do it without the mains connected, so it's not dangerous in any way, but it is a little bit more invasive than pretty much everything else. Some of the tools will have bits and pieces where you can actually talk to the standard firmware, but I wanted to run my own firmware. I didn't want to go to the cloud, so I did that. So that was kind of cool. I plugged one of those into the lights. And then once I had the lights, I had an Alexa in the house. So this is the bit where it does go outside the house. The Alexa does go outside the house and come back, and I did deliberate over it given security concerns. But Home Assistant actually logs all the requests that comes in, and I'm not sharing any information outside the house. So it's not like this knows the temperature. I don't feed any information out to it. What happens is the Alexa will feed a request in that then comes into Home Assistant that says turn on a light. And it's quite good, especially for visitors. There's one of these sits in our dining room, and it means people can sort of ask lights to be turned on and off without having to get access to the web interface or even care what's running under the hood. It just looks to them like a normal person's home automation setup rather than someone who has too much time in his hands or doesn't have enough time in his hands but makes it anyway. And so that was good. I had lights, I had heating. So I wired up my doorbell. And you laugh, and part of it was the doorbell's there. We just took up the doorbell, right? That's got to be easy, right? Actually, turns out to be harder than I thought, and I just cheated. And this is the control panel of the doorbell, and there's a pin on it that goes high when the doorbell rings, and I wired a microcontroller into it. It looks like you've pushed a button, and that works. I wish I had a picture of the inside of the doorbell, because as my co-worker describes it, I build electronics that look like bombs. It's just a mess of wires and everything. I'm not good at the beauty side of things, but it does work. And what's more is, so it notifies via Alexa. Alexa chimes whenever it rings, which is good, because there are bits in the house where we can't hear it. And the day after I made this, we were sitting having lunch, and we had some music on, and Alexa chimed, and we were like, does that mean the doorbell's rang? And we went to the door, and it was in fact a delivery for my wife that we had not been expecting. And so, within a day it was like, hey, it's useful, that's handy. And if you want to be nosy, you can then, because it's logged, you can see when someone rang your doorbell. It doesn't do any of the fancy stuff of like ring or sound or whatever, but it is actually more useful. It was one of these examples of I built it because I could, and then it turned out to actually be quite useful. So that was good. This is my favorite, right? I have a junk room at the top of the house. We don't really have attic space in order to put things in, so it turned out to be the junk room. And I have a Pico projector. This is a tiny Pico projector. It hates light, but that's okay, because this room only has a small window. And so I made it a cinema room. And I hooked various bits up into it. And then it turned out that I'd hooked enough bits together that it became really useful, because this hates light. Like, to the extent you have to have all the lights out and the curtains closed and the door shut. It's like a proper cinema, which then means it's hard to see things in it. So, and the projector needs turned on, and there's a wire around this. So I put all of this stuff on a single power switch, and I hooked the lights in, and I had a Kodi box playing with it. And the first thing we did was, a single button turned it all on. So a single button did wake on LAN, on the web interface, did wake on LAN for the media box, turned on the AV, turned on the projector, turned on the lights, all good. And then the really nice bit, this is what I really like. You press play on Kodi, it goes, hey, you press play on Kodi, and turns out the lights. and you press pause on Kodi, it goes, hey, you press pause on Kodi and turns on the lights. So it sorts it out, and that's like so simple. And it really was a case of, well, I glued all the bits together and I was like, well, what could I do with it? And I would never have told you that was where I was going to end up. And then the other problem is it's the top of the house, it doesn't get used very often. You turn the heating on whenever you went in the room, and then I'd forget to turn it off, and like a week later I'd realize I'd been heating a room all week that I wasn't using. So then I found like 20 quid Bluetooth radiator thermostat adapters. So it talks Bluetooth and you can tell it a target temperature. So now when you hit activate in the room, it turns the temperature in the room up to sort of 18 degrees, and that's all good. And then whenever the AV equipment has already been powered off and you turn out the lights, it goes, hey, you're done in here, and it turns the temperature back down to 5 degrees. So that's really nice, and it fits in, and it's like a scene, and it was an unexpected outcome, and this is my favorite example. The room is much more comfortable these days. I just really like this picture because we did sit in like for 6 months in it like this, 2 deck chairs and big screen there. I've got more. I'll keep going until Ruth shouts at me, because the main thing I'd want to tell you was the heating. More lights. This was one of these things where sometimes you don't realize how home automation can be useful. We had our, I've got to wrap up. We had a kid in January, and that was good, but feeding at night, you don't want to turn on the main light in the room because it wakes kid up. And at one point my wife went, oh, it'd be really useful if I could turn the light in the corner of the room on before I get out of bed. And I'm like, oh, I didn't realize that was a useful thing. I've got a spare power adapter, and 5 minutes later it was all plugged in. Sometimes you just need to have a conversation with the other people who are using the same as anything. What might you want? So that was more lights, and that was actually a useful one about, hey, I can turn the lights on for bed and it's in the corner of the room and it's all good. And I've actually ended up building these. These are WS2812 RGB LED strips, but this is on top of a wardrobe, and then it's a nice uplighter. So this is the IoT PCB I ended up building. I'm going to have to skip through this, but there's a blog post and you can read about it. This is sort of things I'm looking at next in terms of Zigbee is the obvious one, Philips Hue Tradfi, wireless connection around the house, builds a home network, easier to integrate into. External temperature monitor, so I want to see what the temperature's like outside. Some energy meter monitoring, just to generally link it in. The blinds, I would really quite like it if the cinema room actually closed the blinds as well, but that's a bit into the mechanic side of things, and I'm not great at that yet. And the other one, this one is one I'm really conflicted about. We've got motion sensors in a lot of the house for the burglar alarm, and there is actually this project connected which can plug in and replace your old burglar alarm, put it on the web. And I just don't know if I want to trust my burglar alarm to software or fully software. Do I trust my software enough to be able to do this or not? Equally, do I have any faith that the burglar alarm is as reliable as I hope it would be? So I think there are some advantages certainly in piggybacking on all of the sensors that are available from the burglar alarm. Things like turning the kitchen light on. If you wake up in the middle of the night and you're down for a glass of water, that the lights will come on and turn themselves off 5 minutes later would be great. That's a good advantage. Do I want it automatically arming the house whenever it thinks I've left it? I don't think I do. I think I always want that keypad. Otherwise, when the power over Ethernet goes out next time, it'll think I've left the house and the burglar alarm will go off, and I won't be cold at 6:30 in the morning. I'll be woken up at 3:30 in the morning. So that's kind of where I'm at. So yeah, that was actually filled my time quite nicely, and I don't think there's any time for questions, so I am around for the rest of the day, so you can bug me.
You were saying about security, so you had the Bluetooth modules there, which are
oh, they're terrible security. Like a 433 megahertz you can watch, the Bluetooth modules, all the low energy stuff, you can just sniff.
Okay, but you could also sniff your heating in the sense that you could just sit outside and switch something off.
So I have this, the various names for the sort of knock on a door and run. I mean, a lot of doorbells these days are 433 megahertz. You could just build a Pringles can antenna and ring all the doorbells in your street. There's no security. You're relying on either there's enough other noise going on in distance or whatever. There are some security. The bits that are Bluetooth and 433 don't have as much security as I would like. It's only the Wi-Fi stuff that I've actually got full TLS enabled on.
What's the Bluetooth LED range like then in a house? Like any experience from block walls or anything like that?
So the really annoying thing is that modern Bluetooth USB devices don't come with external antennas. But if you take them apart and solder on a standard Wi-Fi antenna, because they're both 2.4 gigahertz, you get good range. I live off the Omer Road, and the number of car entertainment systems that wave at my Bluetooth device as they go past, and that's, this is the back of the house. You need an external antenna. What it actually is that my server with the Bluetooth dongle is literally just below the bathroom, and it gets okay range on that, but it doesn't get further than that. So the Bluetooth range is a bit limited, which is one of the reasons why I didn't want to tie everything off Home Assistant directly, in terms of being able to sort of spread things out and link them back to a central point.